Welcome back, my friends. We are now on our seventh segment of our continuing series about proper nutrition for health. Remember to watch the beginning of this series to the last segment so you will understand the background of these nutrients. We are going to talk about vitamins. Vitamins are micronutrients that are organic in nature and are essential for life because without it, the body would not survive. However, they are needed in small amounts only. They have specific functions that promotes growth, reproduction, and of course, to be alive. My analogy on this is that they are like car spark plugs, except for the newer vehicles that crank up on a coil, unplug, or COP ignitions. All other vehicles that run on gasoline must have spark plugs to start the engine. Vitamins work in similar fashion, but in the human body. Vitamins differ from the macronutrients called carbohydrates, proteins, and fats in several ways. For example, in structure, vitamins are individual units. They are not, again I repeat, they are not linked together. While the macronutrients, for example carbohydrates, are linked together as molecules of glucose, while proteins are linked together as molecules of amino acids, and fats are linked together as molecules of fatty acids. In function, vitamins, when broken down in the body, they do not produce energy. They help the enzymes or circuit breakers that release energy from carbohydrates. So, in essence, vitamins don't really make you strong directly. They require the macronutrients for you to be strong. In food contents, vitamins from food and the body's requirements of vitamins are measured in micrograms. Simply, they are micronutrients, while the macronutrients called carbohydrates, protein, and fats are measured in grams. The important thing to remember about vitamins is that about their bioavailability. This means how they are absorbed and how well they are used in the body. The bioavailability of vitamins is influenced by the following circumstances. For example, efficiency of digestion and time, or how they move in the gastrointestinal tract. In previous nutrient intake and nutrition status of the individual, is there any condition of vitamin deficiency already existing? Other foods consumed at the same time, is there other food containing nutrients that promote its absorption or work against it? For example, it is recommended that vitamin D supplements should be taken with milk to enhance absorption. In food preparation, whether it's raw, cooked, or processed, vitamins are organic, so they are easily destroyed. And this will be explained further in the following pages. Vitamin sources. Is it synthetic? Is it fortified? Or is it directly from food? This factor is influenced from the way it is described from factor 1, 2, 3, and 4. As mentioned, vitamins are organic in nature, which means they have carbons, and as such, they can easily be destroyed by the way they are processed and handled. For example, prolonged cooking in heat destroys vitamin B1 called thiamine. Thiamine is responsible for helping in the breakdown of carbohydrates to provide energy. Another example is vitamin B2 called riboflavin, which can be destroyed by ultraviolet light. This vitamin is found largely in milk, so they must be in a protective container. Vitamin C in fruits and vegetables are oxidized, meaning they are easily destroyed by oxygen when exposed to air after being cut, and so they must be eaten right away after being cut. As most people know, vitamin C is responsible for building a strong immune system. There are two kinds of vitamins. Number one is water-soluble vitamins, and they are vitamin B1, thiamine, B2, riboflavin, B3, niacin, B5, pantothenic acid, B6, pyridoxine, B7, biotin, B9, folate or folic acid, B12, cobalamin, and vitamin C. The second type of vitamin, classes of vitamin, is fat-soluble vitamins. They are vitamin A, D, E, and K. From a nutritional standpoint, macronutrients, which are from foods, are required to absorb the micronutrients. This means that you must eat foods for the vitamins to be absorbed efficiently. In our macronutrient presentations, the term hydrophilic and hydrophobic were discussed. In short review, hydrophilic means water friendly, while hydrophobic separate from the watery fluid space in the GI tract. Vitamins are processed in the body in similar divisive way. For example, the B vitamins and vitamin C are water soluble, meaning they are hydrophilic, and are usually found in the watery space or compartment. Once eaten, they move directly in the bloodstream and travel freely in the body's water-filled compartment to their final destinations. While the fat-soluble vitamins, vitamin A, D, E, and K, are hydrophobic and are normally found in food fats and oils. They first must enter the lymph before they go into the bloodstream. They require protein carriers to travel and are held up in the fatty tissues and the liver until the body calls for their needs. Vitamins are powerful substances, as already known, because without them, the body will be in turmoil. For example, a deficiency in vitamin A can cause blindness, while lack of niacin, which is a member of the B vitamins family, can cause dementia. And vitamin D deficiency can retard bone growth. Vitamins in foods are inactive, and they come in as precursors or forerunners, all also known as provitamins. Precursors are compounds that with the help of enzymes they can be converted into active vitamins. Once you eat them, the body changes them chemically into active vitamins. So how are vitamins processed or activated in the body? Here is an example, as shown in this illustration. It simply explains the pathway of how vitamin D is processed in the body from its original source. Thank you again, and stay tuned for our last segment, minerals, because once we are finished with this, we will start our live video presentation. Thank you again.